Hello students, welcome to the basic series of AAA Chemistry. AAA Chemistry. Actually we are doing chemistry basics. So in this class we are going to see about IUPAC naming to monofunctional group compounds. You see there are three main branches in chemistry: organic chemistry, inorganic chemistry, and physical chemistry. Actually, inorganic chemistry is mostly what it is memory based. It is what memory based. Okay. Physical chemistry is mostly numerical based. Physical chemistry is numerical based, but organic chemistry is understanding based. Okay. In order to understand organic chemistry, you must be very strong in the fundamentals. You must be very strong in the basic things. Okay, then only you can easily understand and you can enjoy organic. Organic is the subject which is to be understood and to be enjoyed and to be played also. Okay, so you have to get very much strong basics in organic. So let us continue our class. Okay, so IUPAC naming to monofunctional groups. In the previous classes, we have seen about the some names to organic compounds: alkane, alkene, alkyne, alkyl groups. Okay. But for not all the compounds, we can give the names, common names. The names are called as what? Common names, which is based on the number of carbons and based on some groups also. Okay, so in order to give so names to each and every compound, the one international committee is there. They are framing some rules. According to that rules only, IUPAC names are given to all the organic compounds. IUPAC, it is like what? Panchayat board in board in chemistry. Okay, so IUPAC. The expansion for IUPAC is I for international, U for union, P pure, A applied, C chemistry. International union of pure and applied chemistry. Okay. So what is the necessity to give IUPAC names to organic compounds? What is the necessity? Already we have seen we can give names to organic compounds, Okay. Methane, ethane, like that we have given. Okay. What's the necessity for giving this type of names? Okay, let us see. First, let us focus on alkanes. What? Alkanes. So already we know about alkanes. Alkanes are the organic compounds having molecular formula, general molecular formula CnH2n plus 2. CnH2n plus 2. Okay, right. So this is the general molecular formula for alkanes. Okay. In this, we are going to give values for n as what? In the previous classes, we have given the value for n as 5. Up to 5 we have given. So in this class, let us start with the 6, number 6. We give value for n as 6. Okay, right. So if you give value for n as 6, then what you will get? Let us see. I draw one table. Okay. So I separate some columns. In the first columns, let us write the molecular. Okay. Structure of the compound in the first column. Structure of the compound in the first column, and then followed by common name. And then IUPAC name. And then what? IUPAC name. Okay. So which is the general molecular formula for alkanes? CnH2n plus 2. Okay. So in this formula, if you give the value for n as 6, then you will get what? C6H 2 into 6, 12. 12 plus 2, 14. So C6H14. Since C6H14 falls in this general formula, it must be an alkane. We know that alkanes are the organic compounds having carbon-carbon single bond. There will be single bond between carbons. Okay. They are actually hydrocarbons. So carbon and hydrogen. These are the two elements present in alkanes. Okay. So let us see the possible structures in this C6H14. Okay, so there are 6 carbon atoms. So we can assume those 6 carbons may be in the continuous manner. C bond C bond C bond C bond C. How many C? 1, 2, 3, 4, 5 C. You see there are 6 carbons. 1, 2, 3, 4, 5, 6. So this is the this can be one type of structure. Another will be C bond C bond C bond C bond C. How many carbons? 1, 2, 3, 4, 5. One carbon I write in the branched manner. Okay, one carbon in the branched manner. Okay, right. And if you write one carbon in the branched manner in this area, these two are identical. These two are identical. Okay, identical position with respect to each other. So these two positions are identical. Okay. What about one carbon at a branch here? Here. But this is a different position. What? This is different position. Okay. Right. Is there any possibility to write other compounds? So this is different. C bond, C bond, C bond. How many carbons? 4 carbons. One carbon here and one more carbon here. You see, these are different. These are different. Okay, right. Is there any possibility for some other? So this is 4 carbons. These 2 branches can be written in the same compound. Same carbon. Same carbon. C bond C. Okay. So in the straight chain there are 4 carbons. 2 are branched with the same carbon. Here also the straight chain has 4 carbons, but 2 carbons are branched in the adjacent positions. Adjacent positions. Okay. So how many carbon skeletons? These are all called as what? Carbon skeletons. Skeleton. Okay. Without hydrogen, we can say this has what? Carbon skeletons. How many different types of carbon skeletons are here? This is one. These 2 are identical only. So this is one type. This is another type. 2. This is 3. This is 4. This is 5. Okay, so with this C6H14, first by taking 6 carbons, I have written these 5 different types of structure, 5 different types of structures. So there are 5 different types of carbon skeletons. Let us fill with hydrogens. We know that the valency of carbon in all the organic compounds is 4 and the valency of nitrogen is actually 3. And the valency of oxygen is 2, and for the valency for hydrogen is 1, and for hydrogen the valency is 1. Okay, so 1, 2, 3, 4. HONC 1, 2, 3, 4. Okay, right. Let us fill with hydrogen. So one bond means already one valency filled. So for 4 valencies, I write H3. Each hydrogen carries 1 bond. So 3 hydrogens means 3 bonds. Already 1 bond is there. So 3 plus 1, 4. So for this adjacent corner carbon, 4 valency is satisfied. So here also I write CH3. So okay. So all the corner carbon with only 1 bond will have 3 hydrogen atoms. All the corner carbons with only 1 bond will have 3 hydrogen atoms actually. Okay. So I write CH3, CH3, CH3. I give 3 hydrogen atoms to all the corner carbons. Cornered carbons. Okay. CH3, 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 CH3. Here CH3, 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 here CH3. So all the corner carbons will have what? H3 along with the 1 bond. Okay, totally 4 valencies have been satisfied. What about if the carbon has 2 valencies, 2 bonds around it, then what will be? So 2 bonds means what? H2. 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 So for 2 bonds around a carbon, we must include 2 hydrogen atoms, H2. 2 bonds means what? H2. 2 bonds means what? H2. 2 bonds, so H2. 2 bonds, so H2. What about here? 2 bonds, so H2. Okay. Okay, so 2 bonds means H2. If the carbon has 3 bonds around it, 1, 2, 3, there are 3 bonds around this carbon, then for this carbon, only 1 valence is needed. So for this we give only one hydrogen. So H. For this carbon also H. For this carbon also H. Here also this carbon has 3 bonds around it, so we give one hydrogen. Here also 3 bonds, so one hydrogen. Here you see this carbon has 4 bonds around it, so there is no need to give any hydrogens to this carbon because its valency 4 is already satisfied. Okay, so we have written actually 1, 2, 3, 4, 5 different alkanes with the molecular formula C6 as H14. Okay, shall we check whether these compounds have 6 carbons and 14 hydrogens? We know that all these have 6 carbons. Are they having 14 hydrogens in it? You see, let us check. 3 plus 2 for this compound, 3 plus 2, 5, 5 plus 2, 7, plus 2, 9, plus 2, 11, 11 plus 3, 14. Okay, 3, 5, 7, 10, 11, 14. Okay, 3, these two are identical actually. These two are what? Identical. Okay, so 3, 3, 6, 7, 9, 11, 14. 3, 5, 6, 9, 11, 14. 3, 6, 7, 8, 11, 14. 3, 5, 8, 11, 14. So all these have 14 hydrogens also. So all these compounds have 6 carbons and 14 hydrogens as the molecular formula. Okay, so molecular formula. So the general molecular formula for alkanes is CnH2n plus 2, and if the value for N is 6, given 6, then we get C6H14. This is the molecular formula. Okay, in this molecular formula, we can write 5 different alkenes. Okay, already I have asked one question to you. What is the necessity to give IUPAC names? Is there any necessity? Yes. Let us see. So let us see this first compound first. This carbon has 6 carbons. Okay, 6 carbons means the root word must be eggs. Okay, let us give first common name. Okay, so eggs. All the carbons have single bonds around it, so it must be an alkane. So N. For all the alkanes, the name will end with N. N means alkane. Okay, so hexane. All the carbons are in the linear manner, in the normal manner. So we are giving one small letter N for normals. Okay, so N-hexane. So the name of the first compound is what? N-hexane. Okay, right. What about the second one? These two are identical actually. Okay, right. So already in the previous class I have told that if two methyl groups, CH3 is called as what? Methyl group. So methyl. If two methyl group is attached with CH, then this part is called as actually iso. What is actually iso? Whenever CH is attached with the two methyl groups, then we can give the name as iso. Okay, so totally this also has what? 6 carbons. So the root word is what? Eggs. So here also there is single bond between the carbon atoms. So the name should end with ane because of alkane. Alkanes are the compounds having carbon-carbon single bond. Okay, so this is isohexane we can give. You can give what? Isohexane. Okay, right. Okay, this is also what? Isohexane because these two are identical as I told. So here you see CH, 2 methyl groups. So this is iso. So 6 carbons hex, then alkane. So isohexane. These two are identical. Okay, what about this compound? Can we give iso to this compound? Iso? How can we give also? If CH is attached with 2 methyl groups, you see this is CH, this is methyl, there is one more methyl. Here CH2, here also CH2. Sir, here is one CH, sir. No. The two CH3 groups, 2 methyl groups must be attached with CH directly, not one carbon away. So this compound, for this compound, we cannot give the name as iso. Okay, right. Then what should be the name for this compound? What should be the common name for this compound? We can't. Can we give any name? No. Okay, right. Then what for this compound? So this is, you see, CH, 2 methyl groups. So iso. Here iso. Here also iso. But what should be given? iso, diiso. No. So simply isohexane. If we give, can we give simply isohexane? No, we should not, because the isohexane name already was given here, has been given here. Okay, so here also we can't give isohexane. So for this compound also we can't give the common name. We can't give the common name. Okay, what about the last compound? Last compound. Last compound has, you see, this carbon has 4 bonds around it, and these 4 bonds have been attached with the alkyl groups. If one carbon is attached with 4 alkyl groups, then the name will be neo. Already we have seen this word neo in neopentane. One carbon will be surrounded by 4 methyl groups. That is called as neopentane. Here also there are 3 methyl groups, but instead of one more methyl group, ethyl group is there. Okay, so around this carbon 3 methyl groups and 1 ethyl group. So totally 6 carbons. So since this carbon is surrounded by 4 alkyl groups, then the name neo should be given. So totally 6 carbons. So the root word is eggs. There is a single bond between all the carbon atoms. So the name ane. It should end with what? Ane. So this is neohexane. Okay. So among these 5 compounds, we can give common names only to the 3 compounds. What about the other 2? We can't give common names. Okay. So actually, common name can't be given to all the organic compounds. Okay, here the question arises. So what should be the name for these compounds? Here the IUPAC, which is International Committee for Organic, okay, actually it comes and gives some rules. Okay, based on that rules only, we are giving some new names to the organic compounds for which we can't give common names. But here one more thing you want to make clear, that not only to the organic compounds for which we can't give common names, for them only we are giving IUPAC names. Not only those compounds, we can give IUPAC names to the already common name given compounds. For them also we can give IUPAC names. Okay, so simply I want to say that for all the organic compounds we can give IUPAC names. Okay, there may be some exceptions. I will see it later. Okay. But what is the necessity of IUPAC name? For some compounds, okay, we can't give common name. But not very few. There are a lot of compounds for which we can't give common names. For those compounds, according to some rules, the IUPAC names are given. Okay. Let us give the IUPAC names to compound number 3 and compound number 4. Okay, right. Let us see. So while giving, so for these compounds, common names cannot be given. Okay, so let us write one hyphen or dash here. Okay, so let us write IUPAC name. Okay, so IUPAC name. While giving IUPAC names, we have to follow some rules. The first rule is we have to find out continuous carbon chain. We have to find out what? Continuous carbon chain. Based on the continuous carbon chain, we have to choose the root word what? Alk. Based on the number of carbons in the continuous carbon chain, we have to choose what? The root word alk. If the continuous carbon chain has only 1 carbon, the root word will be meth. 2 carbons means eth. This already we have seen. 3 means prop, 4 means but, 5 means pent, ex, hept, act, like that. Okay. Then if there are only single bonds between carbon atoms, then with alk we should add what? Ane. If there is any double bond, then ene. If there is any triple bond, ine. So with alk only we are adding ane, ene or ine. Okay. Then with these 3 we have to add one more also. If there is any functional group, then we have to give the name to that functional group. I am simply writing FG, functional group. Okay. And if there is any substituent group, that the name of the substituent group should be placed prior to the root word alk. prior to the root word alk, then it is called as prefix actually. So here we have to write substituent. Substituent. Okay. So the alk is at the middle. We have to consider before alk it is some substituent groups. After alk, yen, yin, ein. Along with yen, yin, ein, the name of the functional group should be added. This is the general rule we have to follow while giving IUPAC. So in the case of alkanes, okay, we have carbon atoms. How many? So let us see the first compound. Here there are 6 carbons in the continuous manner. In the continuous manner, C, 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 C. In the continuous manner. This is the longest carbon chain. Okay, there are 6 carbons. So the root word is eggs. The root word is what? Eggs. Eggs. There are single bonds only between carbon atoms. So yen. So what? Yen. X plus N, Xn. Is there any substituent other than 6 carbons? No. Is there any functional group other than 6 carbons? No. So the IUPAC name for this compound is simply what? Hexane. What? Hexane. Okay. Very good. Okay. So the second compound. Let us see the second compound. The common name was already given as isohexane. Isohexane. Now we are going to give what? IUPAC name. Now we are going to give what? IUPAC names. Okay, so while giving IUPAC name, we have to see the compound, then we have to select the continuous carbon chain. Continuous carbon chain, not only simply continuous, the carbon chain should be what? Longest. Continuous, longest carbon chain. It should be clear. Continuous, longest. The carbon should go as long as possible. The carbon chain should go as long as possible. Okay, so you see. 1, 2, 3. Continuously only 3 carbons we can number. Okay. It is very low number. Let us try once more. 1, 2, 3, 4, 5. So if you give numbers like this, we can get what? 5 numbers. Okay. Up to 5 we can give. Okay. Okay. So 1, 2, 3, 4, 5. So if you give from left to right, 1, 2, 3, 4, 5. So here also what? Up to 5. So this must be the continuous longest carbon chain. We must select. So the long carbon chain must contain more number of carbon atoms. Okay. So in that way we have to select. Okay. Right. So 1, 2, 3, 4, 5. So we have followed the first rule. We have selected. We have chosen the continuous longest carbon chain. Okay. The next is what? If you give number from starting from right side. Now here this group is what? Called as substituent group. So this CH3 is now called as what? Methyl or methyl. Methyl or methyl. If you start giving number from this side, the number for methyl group is 2. Then if you start giving number from here 1, 2, 3, 4, 5, now the methyl group will get number as 4. Which should be given? Which is the position of methyl group? Whether 2 or 4. Here the rule comes. Here the rule comes. Second rule is, okay, the substituent group should get the lowest number. Okay, the location. Now the location of the substituent group must be lowest. So simply this can be written as lowest locant. Lowest locant rule. You have to follow what? Lowest locant rule. That means what? Substituent should get lowest possible number. Lowest possible number. So this is the second rule. So we have to follow the second rule here. So that we have to give numbers starting from here. So 1, 2, 3, 4, 5. So in the second position only, methyl group is there. That being a substituent group, this methyl should be written in before what? Alkyl. Before alkyl. So methyl. That methyl, the position of methyl is 2. So there should be a hyphen between number and word. So 2-methyl. So 2-methyl has been written. The remaining 5 carbons. The root word is pent. And there are only single bonds. So the name should end with ane. So 2-methylpentane. The IUPAC name for isohexane is what? 2-methylpentane. You see. What about this compound? I already have told that these two are identical. We should not say as these two are same. No. We should not say them They are same. No, they are identical. One and only. There is no difference. அது அதே தான். Okay, right. So if you write this compound like this means, then you have to start giving number 1 from here. Number 1 from here, not from here. Then only this methyl group will get the lowest number, what? 2. So 2, 3, 4, 5. So this is the correct way giving the numbers. If you start from here, this methyl group will get number 4. Actually, this is wrong. You have to follow the rule number 2, which is about lowest log control. What does it mean? The substance should get the lowest possible number. While numbering, the substance should get the lowest possible number. Okay, so this is also 2-methyl-pentane. 2-methyl-pentane. So isohexane, the IUPAC name is 2-methyl-pentane. Okay, what about the third compound? Already we know that third and fourth do not have the common names. They have only IUPAC names. Okay, we can easily give the IUPAC name to this compound. Here also, there is a branch. We have to choose what? Continuous longest carbon chain. 1, 2, 3, 4, 5. If you count from here 1, 2, 3, then go down. You get only 4. 1, 2, 3, 4 only. If you go either from left to right or right to left. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Same numbers only. Okay. Now you have to concentrate in giving the numbers to the substance group. If you start 1 from here, now the substance will get what? Number 3. If you start from here, 1, 2, 3. Here also the substance methyl group is getting number 3. So you can start from anywhere of the carbon, anywhere from the terminal, any terminal you can start. Okay, so 3, 4, 5. 3, 4, 5. Both are correct. Okay, so there is a substance group at the third carbon. So 3-methyl. The substance name is what actually? CH3-methyl. So 3-methyl or 3-methyl. So 5 carbons remaining. After writing this methyl, how many carbons are there? 5 carbons. So 5 means what is the root word? Pent. Then what should be written? There are only single bonds between carbon atoms. So the name N. So 3-methyl-pentane. 3-methyl-pentane. Okay, right. What about fourth compound? For fourth compound, you have to follow the first rule, continuous carbon chain. We have to give numbers 1, 2, 3, 4. This should be the continuous carbon chain. Or 1, 2, 3. Here also we can give 4. Okay, so if you give 4, and this is the carbon chain that is having 4 carbons. If you give here 4, then that is also the same number of carbons in the chain. Okay, right. Okay, if you give start from here also 1, 2, 3, 4. Okay, then what about the position of the substance groups? Methyl. There are 2 methyl groups attached. You see, methyl and methyl. What is the position? If you start from here, this methyl will get number 2 and this methyl will get number 3. Okay, if you start from here, this methyl will get number 2, this methyl will get number 3. So the position of these 2 methyl groups is identical, okay, irrespective of the starting point. Okay, so we can start from anywhere. Okay, so both directions will get the same set of numbers. Okay, so both directions are correct. So we can give the names what? First you have to write the substance names. There are 2 substances. Okay, 2-methyl as well as 3-methyl. So here how we should write? 2, 3. There are 2 methyl groups. If there are identical groups, then if they are actually present number 2 times they are present means we have to put one word, that is di. Okay, if there are 2 identical groups means then we have to give the word what? Di. If 3 means tri, we have to give what? Tri. If 4 means we have to give what? Tetra. Like that it goes on. Okay, actually di and tri, these 2 will come. Okay, so for this compound there are 2 methyl groups at position 2 as well as 3. So 2, 3 both are same only. So di, so methyl. So 2, 3 dimethyl. So 2, 3 dimethyl, it was written remaining 4 carbons. The root word is but, so single bond. So N. So 2,3-dimethyl-butane. 2,3-dimethyl-butane. So this is the IUPAC name of fourth compound. Okay, right. What about the last compound? So the last compound is this one. You see, first you have to follow. Okay. Okay, so first you have to follow the rule number 1. So we have to choose the longest continuous carbon chain. 1, 2, 3. No, 1, 2, 3, 3. 1, 2, 3, 4. 1, 2, 3, 4. Okay, so 1, 2, 3, 4. If you start from here, 1, 2, 3, 4. So there are 2 substituent groups, 2 methyl groups. If you start from here, 1, 2, 3, 4, the position of this methyl group is 2, and for this methyl group is also 2, 2, 2. If you start from here, if you start giving number 1 from here, this methyl group will have 3, this methyl group also will have number 3. Okay, so there are different sets. Actually, what should be the rule is, already we have told that what? Lowest set of locants. That is, if there are 2 groups means, for those 2 groups we are giving 2 numbers. The numbers may be same or different. Okay, so by adding them or by just seeing them, we should say which is the lowest set. You see, this is 2, 2. If you add these 2, 2, the total will be 4. If you add these 3, the total will be 6. Among these 2 groups, which is the lowest set? The first one, 2, 2. So we have to give in such a way that 2, 2 should be in the name. Okay, so we have to give numbers from here, 1, 2, 3, 4. So 2, 2, dimethyl, 2, dimethyl, remaining 4 carbons, but, single bonds, so N. So 2, dimethyl butane. For neohexane, the IUPAC name is what? 2, dimethyl butane. Okay, so like this only, we have to give the IUPAC names. Okay, so while giving IUPAC names, we have to follow some rules. So the most important and very first rule is, you have to find out the continuous longest carbon chain. If there is any substituent group is present, we have to give the number to that substituent position. Always should be what? Least number, lowest in the number. Okay, if there are 2 substituent groups means, when for those 2 groups also we have to give what? Lowest set of locants. Okay, right. So like this we can give the IUPAC names to all the alkanes based on the rules. Okay, so let us finish alkanes with these examples. Okay, so in alkanes we have seen about hexane. So how many hexanes are there? C6H14 is the general, that is molecular formula of the hexane. There are 5 different hexanes are there. 5 different compounds we can write by using the molecular formula C6H14. Okay, right. So with this we finish alkanes. Now let us enter into the next part. After alkanes, let us see about alkenes. What? Alkenes. A-L-K-E-N-E-S. Alkenes. What is the general molecular formula for alkenes? CnH2n. Okay. If you give value for n as 1, there is no alkene having only 1 carbon. If you give number 2 for n, then you will be having C2H4. This is the molecular formula for that alkene. Since this formula falls in this general molecular formula, it must be an alkene. Alkenes are the organic compounds having carbon-carbon double bond. Okay, right. Then how will be the structure of the C2H4? Already we have seen this compound. There must be a double bond between 2 carbon atoms. So for the sake of valency of carbon, we are introducing 2 hydrogens here and 2 here. So CH2 double bond CH2. So this is the structure of CH2 double bond CH2. This is from C2H4. The common name, it is what? Having two carbons. So the common name will have eth. Okay, ethylene. Since it is an alkene, the name ends with ene also in common name. So ethylene. Okay, actually C2H5 group is called as ethyl group. C2H6 is ethane. C2H6 ethane. C2H5 ethyl. C2H4 ethylene. C2H4 ethylene. Okay, right. Let us write the next compound having n is equal to 3. And if n is equal to 3 means C3, 2 into 3, 6, H6, C3, H6. So totally 3 carbons. Since it is an alkene, there must be a double bond between carbon atoms. I have written on double bond. So for carbon valency 4 must be satisfied. So here CH2, here 3 bonds means CH, here only 1 bond means CH3. Okay, so this has 3 carbons. So propyl, actually it is one short of one hydrogen. It has short of one hydrogen from propyl. Okay, so propyl plus ene, so it is propylene. Actually C3H8 is propane, C3H7 is propyl. One hydrogen short from propyl. This is C3H6. Since it is short of one hydrogen from propyl, it is propylene. If it is short of one hydrogen from ethyl, it is ethylene. So this is propylene. Okay, right. Okay, so next let us give value for n as 4. N as 4. Then we have C bond, C bond, C bond, C. How many C? 4C. You see, there are 4 carbons with the 1 double bond. Can we change the position of double bond from here to here? Yes, now the position of double bond changes. Can we give some branch in the carbon chain? Yes, we can give. Along with the double bond? Yes, along with the double bond. So by using 4 carbons, we can give 3 different types of alkenes. All these alkenes will have the molecular formula CnH2n, that is C4H8. C4H8. Shall we fill the hydrogen atoms? Yes. So here CH2, here CH, here CH2, here CH3. What about here? CH3, CH, CH, CH3. Here CH2, 2 bonds are there, so CH2. So here CH3, 1 bond. All the corner carbons will have 3 hydrogens. Corner will have 3 hydrogens. So these 3 have the same molecular formula C4H8. All these 3 have C4H8 as the molecular formula. Okay. What about the common names? Already we are given common names to these compounds. Okay. So this is actually alpha carbon. This is beta carbon. Okay. Where double bond is located, the position starts from here. The first carbon is alpha, then beta, then gamma, delta, it goes on. Since the double bond is between alpha and beta, so the least one, the starting one, the first one, alpha should be written hyphen 4 carbons. So the root word is butyl, short of 1 hydrogen from butyl group, acid of butyl group. So butyl, so alkene, so ene, alpha butylene. This is alpha butylene. What about this one? Alpha, beta, gamma, delta. Okay, so since the double bond is between beta and gamma, so beta, the letter beta should be given. So 4 carbons, so butylene. So beta butylene, beta butylene. What about this? Actually, this has 4 carbons totally, but it looks like it has actually a branch. So yeah, if CH is there, CH with CH, 2 methyl groups are attached, means it is iso. But double bond is there, so it is short of 1 hydrogen, so it is actually isobutylene. Isobutylene. So alpha butylene, beta butylene, isobutylene. These are the 3 alkenes that have the general molecular formula of C4H8. Okay, so these common names already we know actually. But in this class, we are going to see about, we are focusing about what? IUPAC names. So for alkenes, the IUPAC name is nothing but you have to first count the number of carbons. We have to find out the continuous longest carbon chain. So based on the number of carbons, we have to choose the root word alk. What? Root word alk. Since double bond will be there, then for double bond, The IUPAC name will end with what? Ene. So alk plus ene what? Alkene. If there is any substituent group, that substituent group should be written in front of alkyl group. So the substituent should be written in front of the alkyl group. That is alk, root word alk. Substituent should be written in front of the root word alk. Okay. So this is the general IUPAC name of alkenes. Let us write one by one. So ethylene. For ethylene, let us write the IUPAC name. Since ethylene has 2 carbon atoms, the root word is eth. For double bond, it is ene. Since double bond is between first and the second carbon, there is no more carbons. Okay. So since the double bond is between first and second carbons, the least number among these two numbers, 1 and 2, what is 1? So eth 1 ene. Okay. This one no need to write. Okay. So simply ethene. Simply ethene. Enough. Okay. So like that propylene also. Number 1, number 2, number 3. If you give numbers from starting from here, the double bond is located between first and second. If you start giving from here, the double bond is located between the carbons 2 and 3. Which one is correct? The least number 1 and 2. Then what? 2 and 3. 1 and 2 is correct. 2 and 3 is wrong. Okay. So for propylene, we have to give the numbers like this only. This one is correct. Okay. So 3 carbons, the root word is prop. Since the double bond is between first and the second, among this first 1 and 2, the least number is 1. So prop 1 ene. Simply propene is enough. Simply propene is enough. No need to write what? Number 1. Because there is no prop 2 ene. We can't write prop 2 ene. Only one propane is there. So simply if 1 comes, then we can leave it. No need to write it. So propene in these cases. Okay. Right. But here, alpha butylene, shall we give the numbers? Number 1 starts from here, number 2, number 3, number 4. If we give numbers 1, 2, 3 starting from here, then the double bond will get the least number 1. And if you start from here, 1, 2, 3, 4, then the double bond will get the number 3. Which one is correct? 1 is correct. This 3 is wrong. Always to the functional group or to the double bond or triple bond or to the alkyl group, whatever may be, the lowest locant rule. We should follow the lowest locant rule, rule number 2. Okay. So for alpha butylene, actually there are 4 carbon atoms. So the root word is but. Double bond is between first and second. Okay. So 1 ene. Is 1 necessary here? Necessary or not? Should we write 1 here or not? Sir, already you are told that 1 is not needed, like that, But here you have to write 1, number 1. Should write. Why, sir? Because you see the next compound, beta butylene. In the case of beta butylene, you see, let us give a IUPAC name. You can give numbers from any end, starting from here or from here. Both numberings will give the same numbers to the double bond. So yeah, in both cases, the double bond gets the numbers 2, 3 only. 2, 3, 2, 3. Okay, so there is no change in the position of double bond. Okay, so actually there are 4 carbons. So the root word is but. Okay, what about the numbers? The double bond is present between second and third carbons. So among 2 and 3, the least number is 2. And the IUPAC name should end with what? Ene, because of alkene. So this is but2ene. Since but2ene is different from but1ene, in order to distinguish these 2 compounds, we have to give numbers. We have to mention the position of double bond. Because the difference between these 2 is only in the position of double bonds. That's why we have to give the numbers and we have to mention. It is a must. You have to mention the position of double bond. So 1 ene, 2 ene, but1 ene, but2 ene. So these 2 are 2 different compounds, 2 different alkenes. Okay, right, fine. What about isobutylene? The last compound, isobutylene, we have to give numbers. Okay, so 1, 2, 3. Okay, longest carbon chain, or 1, 2, 3 straight also. It is okay. Right. For the sake of difference, I am giving 1, 2, the third carbon at the branch. It is actually not. If you continuously give number 3 here, then this is considered as what? Branch. If you give 1, 2, 3 here, now this is considered as branch. Okay. So 1, 2, 3. If you start from here, 1, 2, 3. What? 1, 2, 3. Now the double bond will get what? 2. Number 2. But if you start from here, 1, 2, 3. Now the double bond will get number 1. Okay. So this is actually the correct way. So 1, 2, 3. In the second carbon, one methyl group is attached. Okay. So 2-methyl. What? 2-methyl. 2-methyl. Okay. So 2-methyl. Remaining 3 carbons. So the root word is prop. The root word is what? Prop. Double bond is between first and second. So 1-ene. 2-methyl prop 1-ene. 2-methyl prop 1-ene. Is this one necessary? Here it is not necessary actually. If you write simply 2-methyl propene means it is also okay. No need to mention the position of this double bond 1. Okay, so this one is not necessary. Okay, so simply if you give propene, 2-methyl propene, it is enough. Okay, fine. Alright, okay. Benzene ring. On the benzene ring, vinyl group is there. What is the name of this compound? Vinyl benzene. What is the name of this compound? Vinyl benzene. Vinyl benzene. Okay. Vinyl benzene is otherwise called as styrene. The common name of this compound already we have seen. What? Styrene. What will be the IUPAC name for this compound? Okay. Let us see. This compound contains 2 carbons here and one benzene ring is attached to here. Okay. So actually, what should be the name? Vinyl benzene. Already we are given. Can we give like this? What? CH double bond CH2. This is the main part. In this main part, this phenyl group is attached means then number 1, number 2. Okay. So 2-phenyl, 2 carbons. So root word is eth. Phenyl is what actually? Substituent. Okay. So the root word is eth. Double bond is there. So ene. So 2-phenyl ethene. 2-phenyl ethene. Okay. So this is also correct. We are giving the importance or we are giving priority to the double bond which is here. But we know that this benzene also has double bond. Then why can't we give the priority to this double bond? Okay, with benzene, this group is attached. So like that also we can give. Now this vinyl benzene can be considered as IUPAC name also. Okay, so here also double bond. Okay, so this is vinyl group. This is actually smaller. This is bigger. So the name should end with the bigger part, which is benzene. So on the benzene or with the benzene, one vinyl group is attached. So if like that means, so it is vinyl benzene. So both are okay. Both are correct only. The styrene is another common name. Okay, right, fine. So what about this compound? CCCC. There are 2 double bonds I have given. So CH2, CH, CH, CH2. So this is one alkene. Let us give the IUPAC name for this compound. What will be the IUPAC name? Okay, so we have to give numbers 1, 2, 3, 4. So there are 4 carbons. You can start from here or from here. From anywhere you can start. If you start from here for this double bond, number 1 will come. If you start from and number 4 for this double bond. If you start from here for this double bond 1 and for this double bond 4. Okay. You can start from anywhere. Okay. So actually 4 carbons. The root word is bute. Okay. The double bond is between 1 and 2. So the least number 1. And also between 3 and 4. So the least number 3. So there are 2 double bonds in this compound. So bute 1, 3. 2 means di. Double bonds, so ene. So bute 1, 3 diene. Actually this is wrong. We have to add one more letter A here. Buta 1, 3 diene. What? Buta 1, 3 diene. Why? Because here D is there. If you're not adding A here means, here what? T and D. Both are consonants. Two consonants will not combine. Two consonants will not combine. That's why we are adding one vowel here, that is A. Okay, so it is buta 1,3-diene, not simply but 1,3-diene. Buta 1,3-diene, it is only correct. Okay, right. So now we have given IUPAC names to some alkenes also. Shall we move to alkynes? Shall we move to alkynes? Yes. Okay. Alkynes. Let us see few alkynes. Alkynes are the organic compounds having carbon-carbon triple bond. Alkynes are the organic compounds having carbon-carbon triple bond. Okay, right.